Hello ladies and gentlemen, and today I'm going to be talking about persistence, which is something that we quickly mentioned in our previous videos when discussing this new proposition that has been published by Bowder Limited. We previously mentioned that this persistence property is what attracts threads with the same frequency and opposite poles together, although on its own this is a very weak force. However, where this persistence is best seen is in bridging the gap in the proton rings, and thus holding the threads in a ring. Otherwise they will just form a linear chain, at the moment the neutron ring broke, becoming a proton. It is also this persistence that binds the electrons together within their rings, and causes the natural electron filling pattern to not always follow Mandelung's rule. So let's have a look at what this persistence actually is. And at the top here we show you the usual diagram of a thread consisting of these two poles. Now in this diagram there's a very abrupt start and end to the thread, i.e. there is no build up from nothing to the thread, nor is there any dying off of the thread afterwards back to nothing. The reason we've used this representation is because it's very clear and easy to understand. However, what it does not show you is the thread's build up and dying off, and it is this that we show you in the bottom diagram. For simplicity we've only showed you one of the poles, but the same is true for all the others. Hence it is this bottom diagram that we've got the build up of the thread, i.e. its persistence shown in black, then the thread itself, i.e. what we've previously shown you in red, and then its persistence again in black as the thread dies off back to nothing. Hence it is these black lines that we're referring to when discussing a thread's persistence, i.e. this build up and dying off before and after the thread. Moving on to the proton, which is a ring of 1835 threads with a one thread wide gap, i.e. where the electron thread existed when this was a complete ring, in other words a neutron. Here we've zoomed in on the ring around its gap. Thus we have all of these threads connected together, shown by the red line. Again, for simplicity, we're only showing you one of the thread's poles. And then the point where the gap exists, and the persistence takes over, shown in black, before the threads start again, shown by the red line taking over. Hence, it is easier to see now how the persistence holds the proton ring together, as this diagram shows. There isn't really a full break in the ring of threads, and it is for this reason that the proton stays as a ring instead of becoming a line. Overall therefore we have seen that persistence is actually the build up and the dying off of a thread to and from nothing. In other words, what we've previously shown you is just the thread itself and not the bits either side, i.e. its persistence. We've also shown you how this persistence is able to sufficiently complete a proton ring, meaning that the threads stay in a ring formation rather than just forming a chain when the complete ring, i.e. a neutron, breaks into a proton and an electron. Well, I hope that you've enjoyed this video. If you'd like to know more information about this proposition, then please do visit our website at www.bowder-limited.co.uk and or see our other videos. Lastly, please note that this proposition has not yet been accepted, so don't use it to answer exam questions. However, we would like to hear your views, opinions and questions regarding it. So, thank you for watching.